Hello everyone, welcome to this session. In this session, I'm going to discuss the details of classes of lever systems. Here, there are different types of the lever systems which are used to load in the hydraulic systems. I'm going to discuss generally how the loading will be taking place and what the force will be acting by the hydraulic system and how it will be determined. And I'm going to take the examples of these different types of the class lever systems with an animation. There are three classes of the lever systems. Okay, those are first class lever systems, second class, and third class. These are classified based on the 3 points: load, hinge point, and the effort. And there, one by one, I'm going to take here to discuss. First one is the first class lever system. In the first class lever system, the hinge point is at the middle and the effort is at one end and load will be at the other end. That we can say in this one, fixed hinge pin is located between the cylinder rod pin and the load rod pin, and their distances we are going to take as a L1 between the cylinder rod pin and the fixed hinge pin, and L2 is between the fixed hinge pin and the load rod pin. And here, how much the force will be applied by the cylinder, that is need to be determined based on the load whatever we are going to carry out. The cylinder load is determined based on that momentum what is acting about the hinge point. There is a counterclockwise moment is equal to clockwise moment, and that can be about hinge point. If you take the cylinder load, that will be in the counterclockwise moment, the F cylinder into L1 cos theta, that is equal to F load. It is a clockwise moment we are going to take like this. Okay, here, and by that we can write F load to L2 cos theta. In this we are going to take counterclockwise. And by this simplification we are going to get the F cylinder is equal to L2 by L1 into F load. If you know the load and the distances about the hinge point from this load rod pin and the cylinder or effort, then we can have this cylinder force. Here examples will take. Here this is the animation of that first class lever system. The fulcrum or a hinge point is at the center, load is at one end, effort is at the other end. The best example for this one, the seesaw. The seesaw, what is there? It is the best example of the first class lever system where the at the center the hinge point is there, other side, both side, one side we can say load and other side there is a effort. Those are continuously changing. Another example is that the scissor, about the center there is a hinge point or a fulcrum is there, and load is applied at one end and effort will be there at the other end. And flying cutter is another example. The effort is at the one end, the fulcrum at the center, and load will be other, at the other end. This is examples of the first class lever system. Then we'll take the second class lever system. In this second class lever system, load point is between the fixed hinge pin and the cylinder rod pin. Okay, there again we are going to take the what effort by the cylinder is acting, the force in the form of force to lift that load in the upward direction, and the load is acting in the downward direction. Here also we are going to take the about the hinge point, the moments, the moment of the load about the hinge point that is acting in the clockwise direction, and this is also acting in the clockwise direction about the load point. And this we can the F cylinder cos pi, the F cylinder about this cos pi, this we can take. Here the two distances are there about the hinge point, L1 plus L2 into cos theta, this angle of the that lever at slant, and the F load is acting here, F load multiplied with this L2 cos theta, the same angle is here also acting. And by that the F cylinder we need to find out. The F cylinder can be given as the L2 cos theta, that cos theta will be get cancels, then L2 by L1 plus of L2 cos pi into F load. By this equation we can find the force required by the cylinder in the second class lever system. The examples of the second class lever system, this is the animation of this second class lever system. The load is at the center, the effort is at one other end, and one end there is a fulcrum or a hinge point. Here we can see the one is a nut crusher, that is effort is applied at the one end, and the load is to be taken at the center, and fulcrum is the other end. And the same here, the concrete carrier, there the hinge point is at one end, and the other end there is a effort, and at the center there is a load. And from this we can see the example of this second class lever system. Moving further, third class lever system. In the third class lever system, the cylinder rod pin is between the load rod pin and the fixed hinge pin, and here the cylinder will be applying the force to lift the load from the other end. What is the load is applied, and again we will take the moment about the this hinge point, and both the moments are again here between the distance L2 L1 plus L2, this load will be acting, and its moment we are going to take, and cylinder load is acting about distance L2 about the hinge point, then that moment we are going to take, that we can write F cylinder cos pi multiplied with the L2 cos theta, L2 cos theta this angle, and other side F load is equal to L1 plus L2 into cos theta. Then F cylinder we are going to find out. F cylinder is equal to L1 plus L2 by L2 cos theta, cos pi multiplied with the F load. By this we can find out the cylinder load, okay, which is required to lift the load according to third class lever system. The examples of this third class lever system are: first, to take the animation of third class lever system. Here the fulcrum is at one end, the other end there is a load, and from the center what the effort is there, that is applied to lift the load. Examples are: first one is a broom, where the one end the fulcrum is there, effort is at the center, and the load is at the other end for the cleaning. Okay. Then shovel is the another example. At the one end we are going to apply the load hinge point, and at the center there is effort, and load is at the other end, and this effort is used for lifting of the load at the other end. And here another example of this third class lever system is the stapler machine. The hinge point or the fulcrum it is at one end, at the center there is a effort, and which is used for the applying the load at the other end. This is about the examples about the third class lever systems. Further moving, the three classes of the lever systems are we can compare. In the first class lever system, the hinge point is at the center, force is at one end, other end there is a load. And in the second class lever system, the center load will be there, at one end there is a force, and other end will be hinge point. The third class lever system, here also the same of the second class lever system. The hinge point is at the one end, the other end there is a load, and at the center there is a force to lift the load. This way we can compare the three classes of the lever systems. Thanks for watching. If you like, share, subscribe and comment.